Hello, my name is Tyler Lavers, and this is Gavin Potts here with Are You For Real? Today's physics topic is the conservation of energy.
I know it sounds complex and all, but it is actually very simple, as long as you follow a few laws and equations. Let's start with energy. Energy is defined as the ability of an object to produce a change in itself or in the world around it.
Now there's a few simple types of energy to remember: kinetic, potential, and thermal. Kinetic energy is energy resulting in motion. Anything with mass that moves has kinetic energy. You find kinetic energy by multiplying 1/2 the mass times velocity squared. Potential energy is just stored energy caused by the force of gravity. This can be shown with any object. As I lift this book, the book gains more potential energy the higher I lift it. When I drop it, the energy rapidly converts to kinetic energy when it accelerates down. You can find potential energy by multiplying the mass, force of gravity, and the height of the object. Another type of energy is thermal energy. Since it's currently impossible to have a machine with 100% efficiency, some of that kinetic and potential energy has to go somewhere. This energy is usually caused by friction, which causes heat. For example, in an incandescent light bulb, only 10% of the energy comes out as light. The rest is wasted as thermal or heat.
Ever wonder what equals mc squared really meant? Albert Einstein believed that every object with mass has some kind of energy, regardless of if it had gravity acting on it. He called this energy mass energy. E stands for energy is equal to mass times the speed of light in a vacuum. Now that we know so much about energy, how is energy conserved?
Well, whenever scientists observe energy leaving a system, they look for new forms into which the energy could have been transferred. This is because the total amount of energy in a system remains constant as long as the system is closed and isolated from external forces.
You might wonder what a closed system is. A closed system is a system that does not gain or lose mass. Since mass is energy, therefore you would not be adding or taking away energy. Therefore, the conservation of energy is defined as, in a closed system, energy can neither be created nor destroyed. Rather, energy is conserved.
Are you for real?
I kid you not, Tyler. Now you might be asking the same thing. To prove it to you, we're going to show you a few examples.
We know that energy is conserved in a closed system now. So you could say energy is equal to kinetic energy plus potential energy.
Let me show you. Just bear with me. This first clip is an example of a successful roller coaster. Notice how the second hump is smaller than the first. This means that the initial energy of the train will carry it over the second hill because it requires less energy. This clip shows a poorly planned roller coaster. The equation kinetic energy initial plus potential energy initial is equal to the final kinetic energy plus the final potential energy. Shows why the car cannot make it over the second hump. The final energy required exceeds the energy of the car. Still don't believe the conservation of energy laws? Maybe a little more extreme example would help.
Pendulums are a great example of the conservation of energy, but this isn't just any plain old pendulum. This pendulum is full of dry ice which could literally freeze my face off. But due to the laws of conservation of energy that we learned, the final energy should never exceed the initial energy, as we learned with the roller coaster. So in other words, this should hopefully not severely injure me. Is that enough to prove the laws of conservation of energy?